The alerting layer is a system figuring out issues on its own in the background and then publishing this out. So this is back to an alert that we saw earlier on. This is an alert which says a particular user has made some configuration changes, and this configuration change was done at a particular router, and it has caused this kind of damage. Most likely, the Cloud RAM services product has gotten affected. All of these devices have gotten affected. It produces all of this information. So how does the system figure out all of this information from the data that it's collecting? And for that, so this is the pipeline that runs in the background. It's a lot of information. So you start from data coming into the collection layer on the left. Data comes in from the left, and this data is then is collected in our data store. So you can imagine a lot of data points come in. At this point, machine learning and statistical algorithms are used to figure out what is good, what is bad. So you take a few, you know that this data is good, so you have a bunch of greens and a bunch of reds. So you don't look at the reds, you don't look at the greens to figure out what's wrong. You then collect all the reds. So now you have a set of reds that are happening. But these reds, all of these reds might not be related to each other. There are clusters of issues. Like for example, that Joe person, they made a change. There's a set of events that got connected to each other. So those are the clusters that get built, and that's what we call correlation trees. Those are, you can think of it as a graph. If two edges are connected, that means this has got something to do with each other. And these graphs are built along those lines, and then you publish that graph into your alerting layer. There is some amount of summarization that happens, which takes a connected graph and then produces the alert that we just saw.
And how it's working, so.
So again, that graph that we just said looks like a dense graph like this. This is not something that we expose to our customers all the time, even though experts might want to see the graph. But under the covers, it's a very dense graph, and somewhere over here, you'll see a configuration change that is like the epicenter of what went on. And there is heavy summarization that happens over here. If you did not have this capability, each of the circles over here would be an alert. You would have to deal with the alert storm. Instead, now you get a single alert, and that alert has enough in it which tells you what really happened. And once you drill down from here through the mechanisms that John showed, you will get access to this graph, so you can do more detailed analysis, but you do not have to deal with right off the bat. Again, one aspect of data democratization, that even people who are not experts in infrastructure get to understand what's going on. And once, yeah, sorry.
So basically, I mean, to summarize this, there's a whole bunch of things that happen, and really the doctor is telling us that it's Bob at 2 a.m. made a change to some BGP route that took down the network.
Yes.
Right, and we get that really fast versus like trying to have to sift through 300 alerts.
Like this is what we usually do. We used to do, right? You would look at things over here, and then humans would say, "Oh yeah, this happened, and this is what might have caused all of that." That's what the machine has done right off the bat. And then once you have this alert could be consumed as is. Most likely not. People then take this alert and map it into a ServiceNow. This is a ServiceNow incident ticket that the system formed on its own. So now the ServiceNow ticket has been formed. It has all the relevant information already curated in it, and then downstream teams can take on and do work from it.
Quick question there. When that ticket gets built, will it automatically put in, or can you select what information you want from the alert to go in? So you collected all that data, right? So you got all those logs, all that sort of stuff. You could also potentially populate like the topology or any of the other things you generated and push that in.
Yes. So that's part of the customization that as part of the managed service, we do a default view. We said this is what we're going to publish in the ServiceNow ticket, but during the managed service engagement, the customer might say, no, I like to see this, and the other. So then our teams would incorporate that into the ticket.
Thank you.
I'm running out of time here. Yeah, so there are other capabilities. Now we started, like we talked about alerting and browsing today, but the system has a lot of other capabilities. People have started using us as a single source of truth. I think we are one of the we have one of the best SNMP collection mechanism that we've implemented. People use us as a front end to ServiceNow because originally all of those alert events would go into ServiceNow and create a lot of tickets in ServiceNow. Now, because we front end that, instead of creating 1,000 tickets, you create one ticket and one incident in ServiceNow. Having a Kubernetes-based environment has helped us deploy on premises, off premises, in our cloud, and grow as we grow as data comes in. You can start small, and then as the data comes in, you can start growing.